an electrical design featuring an 800 amp, 120/208 volt, 3-phase, 4-wire service entrance section using the 6-switch rule with 4 fuse disconnects is not code compliant according to the National Electrical Code. The first code violation is an oversized service entrance section. According to NEC section 230.90, the sum of the service entrance switch ampacities exceeds the service entrance rating. In this design, the sum of the switch ampacities is 1000 amps, which exceeds the 800 amp service entrance rating. Furthermore, the sum of the service entrance fuse ampacities also exceeds the service entrance rating. The fuse ampacities total 1000 amps, again exceeding the 800 amp service entrance rating. The second code violation pertains to disconnects and fuses, specifically NEC section 430.90 and 240.4. These sections dictate that the ampacity of a service entrance switch must be equal to or greater than the ampacity of the fuses protecting it. In this design, 2 3-pole 200 amp switches are protected by 150 amp fuses, violating NEC 430.90. To rectify these code violations and achieve compliance, several steps can be taken. Firstly, increase the ampacity of the service entrance section to 1000 amps to accommodate the combined ampacity of the disconnect switches and fuses. Secondly, ensure that the ampacity of the switches is equal to or greater than the ampacity of the fuses protecting them. The National Electrical Code, or NEC, is a comprehensive set of standards for electrical installations. Its purpose is to safeguard people and property from electrical hazards. It's important to note that the NEC is not law itself, but is widely adopted by state and local jurisdictions. These jurisdictions then enforce the NEC as part of their building codes. Service entrance sections are a critical component of an electrical system. They serve as the connection point between the utility's electrical supply and the building's internal electrical distribution system. The NEC provides specific guidelines for the design and installation of service entrance sections to ensure safety and reliability. The 6-switch rule is a provision within the NEC that allows for up to 6 disconnect switches to serve as the main disconnecting means for a service. This rule provides flexibility in designing service entrances, especially in larger buildings with multiple loads. However, it's essential to adhere to the NEC requirements regarding the sizing and coordination of these disconnect switches. Overcurrent protection, typically provided by fuses or circuit breakers, is a vital safety feature in electrical systems. Overcurrent protection devices are designed to interrupt the flow of electricity in the event of an overload or short circuit, preventing damage to equipment and reducing the risk of fire or electrical shock. Fuses are overcurrent protection devices that contain a fusible link. When an excessive current flows through the fuse, the link melts, opening the circuit and stopping the flow of electricity. Fuses are available in various sizes and types to suit different applications. Circuit breakers are another type of overcurrent protection device. They use a mechanical mechanism to interrupt the circuit in the event of an overcurrent. Circuit breakers can be reset after they trip, making them reusable. Ampacity is a term used to describe the current carrying capacity of a conductor, such as a wire or cable. The NEC provides tables that specify the ampacity of different types and sizes of conductors based on factors such as insulation type, temperature rating, and installation method. It's crucial to select conductors with sufficient ampacity to handle the expected load current to prevent overheating and potential fire hazard. When designing an electrical service entrance, it's essential to perform accurate load calculations to determine the total demand for electricity. Load calculations involve adding up the power requirements of all the electrical equipment and appliances that will be connected to the system. The NEC provides guidelines for calculating loads based on factors such as square footage, occupancy type, and the types of loads served. The calculated load is used to determine the appropriate size of the service entrance conductors, overcurrent protection devices, and other components. Coordination of overcurrent protection devices is crucial to ensure that the electrical system operates safely and reliably. Coordination involves selecting overcurrent protection devices with appropriate characteristics so that the device closest to the fault will trip first, minimizing the extent of the outage. The NEC provides guidance on coordinating overcurrent protection devices to achieve selective tripping. Grounding is another essential aspect of electrical safety. Grounding provides a low impedance path for fault currents to flow back to the source, allowing overcurrent protection devices to trip and clear the fault. Grounding also helps to stabilize voltage and reduce electrical noise. The NEC provides detailed requirements for grounding electrical systems to ensure safety and proper operation. Bonding is the process of connecting different metallic parts of an electrical system together to create an electrically conductive path. Bonding helps to equalize voltage potential and reduce the risk of electrical shock. The NEC provides requirements for bonding various components of an electrical system, such as equipment enclosures, metal conduits, and grounding electrodes. Electrical enclosures are used to protect electrical equipment from physical damage and environmental factors. Enclosures also provide a barrier to prevent accidental contact with energized parts. The NEC specifies requirements for the construction and installation of electrical enclosures to ensure safety and proper operation. Conduit is a type of raceway used to protect and route electrical conductors. Conduit can be made of metal or non-metallic materials and is available in various sizes and types. The NEC provides requirements for the installation of conduit, including support methods, bending radii, and fill capacity. Wiring methods refer to the techniques and materials used to install electrical conductors. The NEC recognizes various wiring methods such as conduit, cable, and surface raceways. Each wiring method has specific requirements for installation, support, and protection. The electrical panels, also known as distribution boards, are used to distribute electrical power to different circuits within a building. Electrical panels contain circuit breakers or fuses that protect each circuit from overcurrents. The NEC provides requirements for the installation and wiring of electrical panels to ensure safety and proper operation. Electrical equipment must be listed and labeled by a recognized testing laboratory to ensure that it meets safety standards. Listing and labeling indicate that the equipment has been tested and found to be suitable for its intended use. The NEC requires that all electrical equipment be listed and labeled. Electrical inspections are conducted by qualified electrical inspectors to verify that electrical installations comply with the NEC and other applicable codes. Electrical inspections help to ensure that electrical systems are installed safely and correctly. Permits are typically required for electrical work to ensure that it is performed by qualified individuals and that it complies with applicable codes. Electrical permits provide a mechanism for tracking electrical work and ensuring that it is inspected. Qualified electrical workers are individuals who have the necessary training and experience to perform electrical work safely and correctly. The NEC requires that electrical work be performed by qualified electrical workers. Electrical safety is a top priority in the electrical industry. Electrical workers must follow safe work practices and use appropriate personal protective equipment to prevent electrical shock and other injuries. Continuing education is essential for electrical workers to stay up to date on the latest codes, standards, and technologies. Continuing education helps to ensure that electrical workers have the knowledge and skills necessary to perform their work safely and effectively. The NEC is updated every 3 years to reflect changes in technology and best practices. It's important for electrical workers to stay informed about the latest revisions to the NEC to ensure that their work complies with current standards. The authority having jurisdiction, or OJ, is the organization responsible for enforcing the NEC and other applicable codes. The AHA may be a local building department, a state electrical board, or another regulatory agency. The AHA has the authority to interpret the NEC and to approve or disapprove electrical installations. The service entrance section of an electrical system is a critical component that requires careful design and installation to ensure safety and reliability. Compliance with the NEC is essential for all electrical installations to protect people and property from electrical hazards. A thorough understanding of the NEC requirements for service entrance sections, overcurrent protection, grounding, bonding, and other aspects of electrical safety is essential for all electrical workers. Regular inspections and maintenance of electrical systems are also important to ensure their continued safe and reliable operation. By following the NEC and adhering to safe work practices, electrical workers can help to prevent electrical accidents and protect the public from electrical hazards. A restaurant electrical service requires careful planning and execution. It's essential to consider the specific electrical needs of the restaurant, including the types of equipment used, the hours of operation, and the number of employees. A well-designed electrical system can help to ensure that the restaurant operates efficiently and safely. It is very important to have all electrical work reviewed by a qualified professional, and the design should be stamped by a licensed engineer if required in a jurisdiction.